My dear students, today we will be discuss about the electric field due to a plane sheet. The plane sheet can be uniformly charged insulator or conductor. First, we study about the uniformly charged non-conducting plane sheet. Suppose a uniformly charged infinity expansive plane sheet of surface density of charge small sigma. We calculate the electric field at the point P of distance small r from the plane sheet. We taken a symmetrical point P dash at the same distance from the plane sheet and drawn an imaginary cylinder having uniform cross-sectional area and passing through from the center of plane sheet touching the point P and P dash. The direction of electric field due to the uniformly charged non-conducting plane sheet is perpendicular away from the plane sheet. We taken a small area element at the both sides of area vector dA of direction is perpendicular from the center of cross section. First, we calculate the electric flux passing through from the area element. The electric flux passing through from the area elements from area element. d phi E is equal to d phi 1 plus d phi 2, or d phi 1 is equal to d phi 2 is equal to E into dA cos theta, where theta is equal to 0. This is because vector E parallel vector dA. We know cos 0 is equal to 1, then d phi 1 is equal to d phi 2 is equal to E into dA. The total electric flux passing through the Gaussian surface. This imaginary cylinder is called Gaussian surface. We calculate the total electric flux passing through from the Gaussian surface or imaginary cylinder. The closed integration d phi E is equal to closed integration d phi 1 plus closed integration d phi 2, or phi E is equal to E into closed integration dA plus E into closed integration dA, where closed integration dA is equal to A, or phi E is equal to 2 into EA. Taken equation 1. According to Gauss law, phi E is equal to Qy of epsilon naught is equal to small sigma into A upon epsilon naught, where Q is equal to small sigma into A. Taken second equation. Compare the equation 1 and 2. Equation 1 and 2 compare. Small sigma into A upon epsilon naught is equal to 2EA. A से A कैंसिल हो जाएगा और E is equal to small sigma upon 2 epsilon naught. It is electric field set up by the uniformly charged infinity expansive plane sheet at any point from near of the plane sheet. The formula does not depend on the distance. E is equal to small sigma upon 2 epsilon naught. We say in other words, the electric field set up by the uniformly charged infinity expansive non-conducting plane sheet have same magnitude at the near of the plane sheet. It does not depend on the distance. It depends on the surface density. The direction of electric field due to the uniformly charged insulator plane sheet is perpendicular away from the plane sheet. Next, electric field due to a uniformly charged conductor plane sheet. Suppose a uniformly charged conductor plane sheet of surface density of charge small sigma. We calculate the electric field due to the uniformly charged plane sheet at a point P. We know given the sum charge given the conductor, the charge uniformly distributed on the surface of conductor. We shall assume the two edges of conductors behave as the two different sheets. The first edge suppose as the first sheet plane sheet and second edge suppose as the second sheet, and E1 E2 is the electric field set up by uniformly charged plane sheet at the point P. We know the electric field at a point due to the charged plane sheet E1 is equal to small sigma upon 2 epsilon naught. The electric field due to the plane sheet at the point P by second surface E2 is equal to small sigma upon 2 epsilon naught. Away from the plate, the direction of electric field away from the plate. The direction of electric field or the direction of E1 and E2 in same direction, then the net electric field at the point P vector E is equal to vector E1 plus vector E2, or mod vector E is equal to small sigma upon 2 epsilon naught plus small sigma upon 2 epsilon naught is equal to small sigma upon epsilon naught. It is formula of electric field due to the uniformly charged conductor plane sheet at any point from near of the plane sheet. Next, electric field due to a uniformly charged two plane sheet have different surface density of charge. Consider the two uniformly charged plane sheet of surface density plus sigma and minus sigma. We calculate the electric field due to the uniformly charged two plane sheet at a point P. If the point P lies from outside and between the two plates. First, if point P outside from the plane sheet. The electric field due to the plane sheet of surface density of charge is plus sigma at the point P. Vector E1 is equal to small sigma upon epsilon naught away from the sheet. The electric field due to the plane sheet of the surface density charge minus sigma. The electric field at the point P due to the sheet of surface density is minus small sigma. Vector E2 is equal to small sigma upon epsilon naught towards from the sheet towards to the sheet. The direction of electric field due to the plus small sigma and minus small sigma have the different direction in opposite direction. The net electric field vector E is equal to vector E1 minus vector E2, or vector E is equal to small sigma upon epsilon naught minus small sigma upon epsilon naught is equal to 0. Okay. So we say the electric field due to the uniformly charges of two plane sheets have different surface density of charge is 0 if the observation point outside from the sheet. If the point P lies between the plane sheet. In this condition, the point P lies between the plane sheet small sigma plus small sigma and minus small sigma surface density of charge. E1 vector E1 is equal to small sigma upon 2 of epsilon naught away from the sheet, and E2 is equal to small sigma upon 2 of epsilon naught towards to the sheet. The E1 and E2 act in the same direction, the net electric field vector E is equal to vector E1 plus vector E2. Vector E is equal to vector E1 plus vector E2, or vector E is equal to small sigma upon 2 of epsilon naught plus small sigma upon 2 of epsilon naught, or vector E is equal to small sigma upon epsilon naught. It is the formula of electric field set up between two plane sheets at the point P.